All right, eighth grade friends, here we go again, continuing to solve systems of linear equations. Now, today is about eliminating but arranging like terms, which means unlike the last 2 days where we had the x's and the y's and the whole numbers all lined up, they're not going to be given to you like that. You're going to have to readjust something so they actually do line up. Okay? So, I have this 2x minus y equals 32, y minus 5x equals 13. I want to line up my like terms, so I'm going to leave this first one the same, and I'm going to rewrite 2x minus y equals 32. But you're going to have to rewrite one of the equations so the like terms line up. So what I'm going to do over here is instead of y minus 5x, I'm going to switch them around and I'm going to make it negative 5x plus y. Remember, this is not just a subtraction sign, it also makes this a negative 5. But it's going to be plus y. So I'm going to come over here and I'm going to do negative 5x plus y equals 13. Now I can do the same thing I've done the last 2 days. In today's assignment, you're going to have to look for whether it's better to add or subtract. They're not separated like they were Monday and Tuesday. All right, you're going to have to decide, do I want to add, do I want to subtract? Well, if I'm looking here, once again, remember what I'm doing. I'm looking to cancel something out to make 0. Now here, clearly, that's going to be the y with the negative y and the plus y. And to make 0, it's essentially going to be negative 1 plus 1. That's going to give me 0. So I'm just going to cross that out as it is. That's going to be my elimination. Now I'm adding negative y plus 1. So I'm adding 2x plus a negative 5. Now we know that 2x plus a negative 5x is essentially the same as 2 minus 5. So that's going to give me negative 3x. And then when I add, since I've been adding 32 plus 13, that's going to equal 45. Now negative 3x equals 45. To find what x equals, it becomes 45 divided by negative 3. Well, 45 divided by negative 3 equals negative 15. So x equals negative 15. Now I want to plug that into one of my equations. Now I'm going to choose this bottom equation because I like the idea that a negative times a negative is going to equal a positive. So I'm going to think negative 5 times negative 15. Well, negative 5 times negative 15 is going to be a positive 75. A negative times a negative is a positive. So that's going to leave me with 75 plus y equals 13. Well, I want to get y by itself, so I'm just going to subtract 75 from both sides. And so now I have this interesting situation of and I would have gotten 13 minus 75. Okay, so when I plug that in, obviously that's going to be a negative. 13 minus 75 is going to be a negative 62. All right, and so I'm going to see that my intersecting point is going to be negative 15, negative 62, and that's going to be my intersection point. Kind of some odd numbers. We don't usually have some smaller numbers than that, but I can assure you that the intersection point for this system of linear equations is negative 15, negative 62. Now, let's kind of clear that a little bit. All right, now let's look at another example. Let's say we have negative 8y plus 6x equals 36, and 6x minus y equals 15. Once again, I have to rewrite one of the equations so that they match up, okay? And the like terms line up. So once again, I'm just going to keep this first one the same. Negative 8y plus 6x equals 36. I'm not going to mess with that one. That one's going to stay the same. This one is going to become negative y plus 6x. So it's going to become negative y plus 6x equals 15. Now, clearly what's going to cancel out is the 6x and the 6x, but we want to make sure that we're knowing whether that's addition or subtraction. Well, clearly that's going to be subtraction. Positive 6 minus positive 6 is 0. So we cancel that out to make that 0. So now I'm subtracting negative 8y minus a negative 1y. So it's essentially negative 8 minus negative 1. This isn't just minus this. I'm subtracting a negative number. So when I subtract a negative number, essentially I'm adding. So negative 8 plus 1, or negative 8 minus a negative 1, is going to give me a negative 7y. And then I'm going to have to subtract 36 minus 15. That's going to equal 21. Well, it's amazing. Usually the numbers work out pretty good 8th grade, as they have in the past. If negative 7y equals 21, I'm going to do 21 divided by negative 7, and that's going to tell me that y equals negative 3. Now, so if I'm going to go plug in negative 3, I'm going to plug it into this first equation, and I'm going to think, well, negative 8 times negative 3 is a positive 24. So that's going to leave me with 24 plus 6x equals 36. Negative 8 times negative 3 is a positive 24. 24 plus 6x equals 36. Well, to solve for x and isolate it, I'm going to have to subtract 24 from both sides. 36 minus 24 is 12, and that's going to leave me with 6x equals 12. If 6x equals 12, I'm going to do 12 divided by 6, and that's going to be 2. So that tells me that x equals 2. And my intersection point is going to be 2, negative 3 for those two lines. All right, so this is arranging the like terms, and then you're using either addition or subtraction to eliminate one and then solve. All right, have a great day, 8th grade. We'll talk to you later. Bye.